Welcome to The Explainer. Today, we're diving into the hardware arms race that's happening right under our noses. We're talking about the specialized chips that are going to power the next big leap in artificial intelligence.
So, let's kick things off with a question that's kind of puzzling. We all know GPUs are king, right? They're what's powering this whole AI revolution. So if that's the case, why are all the tech giants suddenly in this mad dash to build their own custom chips? What's going on there? Let's dig in.
Okay, so here's the game plan. We're going to look at why GPUs, as great as they are, might not be the whole story anymore. Then we'll check out the custom chips the big cloud companies are cooking up, and some really wild designs from the innovators. We'll see how they stack up. And then we'll talk about why this whole race is so incredibly important for what's next in AI.
All right, let's jump right in. To really get what's happening here, you need to understand this one key idea.
Okay, so think about it like this. A GPU, that's your Swiss Army knife. It's awesome, super flexible, and can handle pretty much any AI job you throw at it. But these new, specialized chips, they're more like a surgeon's scalpel. They're not built to do everything. They're built to do one specific job perfectly, with insane speed and efficiency.
And these specialist tools are usually focused on one of two big jobs. First, you've got training. This is the heavy lifting, the marathon. It's like sending the AI model to school, feeding it just massive amounts of data. Then you've got inference. That's the sprint. That's when the model is all trained up and you're just asking it for a quick answer or to generate something. Speed is everything there.
So who's actually building these things? Well, let's start with the big guys, the cloud titans. They're building their own custom silicon, basically to control their own destiny and get a leg up on the competition. Google was way ahead of the curve on this, with their TPUs, their Tensor Processing Units. And this isn't some small experiment. These chips are the absolute heart of their services, running search, Gemini, photos, everything. And they just keep getting better. The V5P, for example, is a total beast for large-scale training, and now they're talking about Trainium, the next version, having a, get this, 4.7 times performance boost. Then there's Ironwood, which is all about making inference crazy fast. Then you've got Amazon Web Services. As the biggest cloud provider, their strategy is super clear. They have two different chips for two different jobs. Trainium is all about making model training cheaper and more efficient for their customers. They're claiming it's got 30 to 40% better price performance than using GPUs. And for the other side of the coin, there's Inferentia. It's built for high-speed, high-volume inference. And they say it can cut the cost of running AI by up to 70%. That's huge. And you know, Microsoft wasn't going to sit on the sidelines. They've thrown their hat in the ring with their own chip, the Azure Maia 100. And its job is pretty straightforward: to be the perfect engine for the massive language models and all the generative AI magic happening inside their Azure cloud. It's all about optimizing their own systems.
Okay, but it's not just the household names in this race. There are some really interesting innovators out there, companies that are completely rethinking how a chip should even be designed.
Take Intel. They're making a huge push with their Gaudi series, and they're not being shy about it. They're aiming squarely at the high-performance training market, going head-to-head with NVIDIA. Their latest chip, Gaudi 3, they claim can offer a better bang for your buck on some key AI jobs.
And then there's Cerebras. These guys came along with a truly wild idea. Instead of linking a bunch of small chips together, they basically asked, what if we just made one single, gigantic chip? And they did. Their wafer-scale engine is literally the biggest chip on the planet. It's so big, it can hold an entire AI model on it, which means you get rid of all the communication bottlenecks between chips.
Yeah, and their claim is just as massive as the chip itself. They position this thing as a way to train models orders of magnitude faster than using a whole cluster of GPUs. For those really, really big problems, this could be a game changer.
Okay, so if Cerebras is all about sheer size, Grok is all about pure blinding speed. They've developed something they call an LPU, a language processing unit, and it has one job and one job only: to be the fastest inference engine on the planet for language models. They're talking up to 18 times faster than a GPU. Just wow.
But here's what really makes you pay attention to Grok. It's not just the speed, which is incredible. They claim their chip delivers that speed while using just a tenth of the energy. That combination of raw performance and incredible efficiency, that's the holy grail right there.
And the list just keeps growing, you know? You've got other key players like Sambanova with their reconfigurable data flow units and Graphcore with their unique memory-first chip designs. Everyone's tackling this problem from a slightly different angle.
Okay,
So we've met the contenders, we've seen all these different approaches and philosophies. But the big question is, how do they actually stack up? Let's get into the performance.
All right, if you look at this table, you can really start to see the different strategies. You've got Google's TPUs focused on that price-to-performance ratio for huge training jobs. AWS is all about cutting costs for their cloud users with their two-chip combo. Then you have the specialists. Intel's Gaudi is going for high throughput. Cerebras is for those monster models, promising to be orders of magnitude faster. And Grok is just all in on that unbelievable inference speed.
And to put some numbers on it, just look at this. This is Intel's claim for their Gaudi 2 chip compared to a top-tier NVIDIA A100 GPU. They're saying it delivers about twice the throughput for training. That's a massive jump, and it's the kind of number that makes the entire industry take notice. So what's the big takeaway from all this? Well, it seems like a trend is emerging. For these huge specialized jobs, like training a gigantic model or running millions of inferences a second, these custom chips are really starting to pull ahead on price and performance. But, and this is a big but, the GPU is still the king of flexibility. That Swiss Army knife is still the best tool for researchers and developers who need to do a little bit of everything.
Okay, so this is all really fascinating tech, but let's take a step back. Why does this race actually matter? For you, for me, for the future of AI?
Because at the end of the day, this is about so much more than which company has the fastest chip. This intense competition is what's fueling the next wave of AI innovation. It's leading to more powerful, more efficient, and importantly, more accessible AI. It's what allows us to even dream of building the kinds of complex models that are on the horizon.
And that really leaves us with the big, fascinating question, doesn't it? As AI keeps getting more and more complex, are we going to see one-chip architecture continue to dominate everything? Or are we at the beginning of a totally new era, like a Cambrian explosion for hardware, with a whole ecosystem of different specialized chips for every possible task? The future is definitely not set in stone.